in this lecture I will be discussing about what is stack data structure. So let's get started. So first I will show some picture for your better understanding, is that you can clearly see that this is the stack of books, that this book after this and then and this. So this is, okay, you can first see this and then we'll starting from that lecture. Okay, so let's get started. So what is the definition of stack? So stack is a linear data structure, means that data is stored at linear fashion. There are two types of things, that like you can store data linearly or non-linearly. What a non-linear data structure, we'll be discussing in some lecture, next lecture, about what are trees data structure. So we will be discussing how data structure, trees, tries, and many more. So here the fashion of storing data is in LIFO order. What is LIFO? Last in, first out. So you can directly see from this picture, like this is the plate, it came at the last and it has to be popped or taken out firstly. So this is how last in and first out works. So this is the first plate, after that this is the last plate. So if you want to remove an element, you can't take this kind of things, you have to remove from this. So this is how the last plate came and it has to be popped at first. So this is the stack of plates. So when you do undo operation, means when you apply control plus z, then the last thing that you have written over there will be deleted. So that can be application of stack. Okay, so what these are the top operations that can be performed using stack, is like push operation, pop operation, top or peek you can say, and is empty. So what is this? So push operation means very simple as compared to the array. Like you want to store something in the stack, so if you want to add an element at the top of the stack, then you can use push operation. What is the next thing is the pop operation. What is pop operation? Pop operation means you have to remove the top element of the stack from the stack. Okay, so remove the top element from the stack, you can use pop operation. After that, top or peek, what it is? Top means what is there at the top. So if you want to view the element which is present at the topmost element in the stack, so you can use this kind of things. If you want to check, like, is your stack is empty or it is full, so if this is returning 1, means that your stack is empty, and if this is returning 0, then it must be like stack is non-empty. Okay, so if we have some picture, then I will definitely show how things will be working. This is, you can easily get that how things has been working. So first thing is this C is pushed over there, so this C is at the top, and if you want to remove, then this top has to be removed and you can pop it. Okay, and the top is pointing to this B. So this is how things will be working. So let's get into the coding part, how we can implement stack using an array. So you can see here how I have implemented all those stuffs. So I have defined a class. If you don't want to define anything, then you can use STL of stack, that you don't need to write all those functions like push pop or peek or is empty. You have to just implement or just do this thing, includes stack, and just you can do anything. But if you want to implement stack from scratch, then you should have to understand how things will be working. So I have created a class called stack, and I have this private specifier, means that this top can't be accessed from this function, from this class, sorry. So this is the top, which will be pointing to the top element of the stack. And for implementation of stack, I'm using array data structure. So I have created an array in ARR of max, and the size of max is 1000. You can do, and you can I'm just creating from stack data structure. You can generate at the heap memory also, like you can use int star ARR is equal to new int. So the same thing can be happen. but I have declared over there. So I'm using a stack based memory. For more knowledge, if you want to know how things will be working and how memory can be stored using stack or heap, I will make some videos over there. Okay, this is the constructor stack, and initially this top is pointing to -1. -1 means there is no element in the stack, means the stack is empty. So this top is equal to 0 is the initial position of the stack. So if you want to push something in the stack, so I have created some boolean function which will be returning either true or false. So this is the element x that I want to push. So there are two conditions that can be happening. First thing, the stack is already full. If you want to push something, and if you want to push any data in the stack and the stack is already full, then you can't basically store anything. So this condition is called overflow. The stack overflow means you don't have your stack is already filled and you can't fill any kind of data. So that's how I have returned false here. And if there is an element which is stored and which is free in the stack, then I have to just do one thing. Initially the top is pointing to -1, then I have to increase from -1 to top plus plus, means the top is pointing to the next element of the array, and at that location I have to store that data. And just I want to print that you have pushed into the stack. That's it. And then after, because it is a boolean kind of function, I'm returning true. If you don't want to do all those stuff, then you can also create some kind of void function or int function, and you can do all those stuffs. Just you have to remove this return thing. If you don't want to write boolean, then if you want to write void function, then you don't have to return anything, you have to just return it. Okay. And this is the pop function. Pop function is very simple. Like, you have to remove element from that array because you are implementing stack using array. So if top is already negative means what? This top is equal to -1, let's say. So if this stack is already empty, then you can't remove anything because it is already empty. So if you really want that, if this stack is equal to -1, then same thing will be working. Like, this stack is already pointing to -1 means there is no element, then you can just write stack is underflow, sorry, and just you have to return 0. So if this pop function is returning 0, means that your stack is already empty. And if you really want to pop something from that element, then you have to just int x, and the int x should be equal to ARR of top minus minus. You can easily understand that if you don't want to do anything, if you really want, just ARR of top minus minus. That's it. If you want to do this thing, then this top is pointing to the previous pointer. Okay, so if you first want to make that pointer is equal to -1, then you want to do anything, then you can also do like that. Like, if you want to, but this is already true, like I have explained to you, but it is a int type of function, then you have to return something. So that's why I'm using this kind of things. Okay, basically it is very simple. Like, if you want to pop something, then your pointer should be pointing to the previous pointer. So that's how popping is done. Means you have to just point the element to the previous pointer. So that's how I have written over there. I'm just returning this x. This x will be pointing to the previous number. So that's how ARR of top minus minus, and I have returned these things. Okay, and if you want to know the peak element of the stack, means that I want to know what is present at the top of the stack. So if the top is already negative, it can be possible only when it is equal to -1. So if the stack is already empty, then there is no top value. So that's how I can write stack is empty and I'm returning 0. Okay, and else condition, I have to just return the element which is at the top, which is ARR of top. So that's how things is working. So the last function for implementing your stack is IsEmpty function. IsEmpty means that is the stack is empty or it is not empty. So if this is true, means like stack is equal to -1, let's say. So if it is true, means it is empty. Either it is true or return true. So it will definitely give you 0, either 0 or 1. So if it is giving you 0, means the stack is empty, and if it is giving 1, it means that stack has some values. So I have created using stack s, and I want to push something like 10, 20, 30, and that's it. And if you I want to pop s dot pop, then I have popped something and I can see the top element. So let's get started and just doing it. So unknown, okay. Okay, it's perfectly fine. Like, I have pushed something. So 10 is pushed into the stack. After that 20 is pushed into the stack, and after that 30 is pushed in the stack. And after that I'm popping 30, because 30 is present at the top position of the stack. So that's how this is popped from the stack. Okay, 30 is popped from the stack. Okay, after that, what will be at the top position? Because 30 is already being deleted from the top position, then 20 will be present. So the top element is 20. So I've explained how stack is implemented. There are these kind of functions. If you want to really, but you have some STL libraries, so you don't need to do all those stuffs. So let's move forward. So this can be your application of stack. Like, if you want to do conversion between is the number is infix or postfix, then you can use the concept of stack. Postfix, for solving problems related to postfix expression, you can use it. Text editing means editors means how I have explained earlier in this lecture. Like, you do command Z or control Z. So that's how you can use some questions related to backtracking, like maze problem and browse history. These can be solved using stack. And function call management, so function call in programming, so how function is calling another function, so you can see from how stack is implemented. Okay, so I have explained that how stack is implemented. So I have used this method, like array based implementation. It is simple and it is fast, and it has also fixed size. So this is the problem over there. And another approach is linked list. So as we know, linked list is dynamic in nature. So but there are so many pointers, so overhead of pointers can be happening over there. So this can be a limitation. So these are the advantages, and these are some disadvantages of stack data structure. Like, stack can be easily implemented and it is efficient, while if you want to do LIFO operation, but the problem is that the limited size in the array based stack, and not suitable for random access. You can't access some data which is present at the random. So this is all about the stack, and after that I will make some videos related to how you can solve problems of stack. So in this video I haven't solved any kind of problem, but I've just explained how stack is implemented, what is a stack, and where it is used in storing data. So thank you for watching this video, guys. So if you really like this video, then please give a thumbs up.